Okay. So I'm Jayme Gruen. I'm the National Manager for Alden Leeds Chemical Company, supplier of the all-chlor products. And I have my business cards here as well with an 800 number. And I invite customers, whether they're direct or through Hatchik, to contact me with unusual water problems. I run a small laboratory out of my home, and I make myself available during the season for any type of consultation. The idea is always to try to solve your own problems first, and it's best to learn and do the research. But if something unusual emerges and you want to talk to me about it, that's an important part of my job during the season. And I've worked out in the field like many of you have over the years, so I have a good understanding of the kind of speed that you need to do, especially in service. Because most of the products that we use in pool chemistry have labels that will suggest to use a product kind of slowly and cautiously. And most service people need to move a little quicker, so my orientation is towards that, away from the homeowner. Now the handouts that you have consist of a total alkalinity guide, a pH plus and minus guide, a calcium hardness guide, and all three of these pages roll up into the monthly chemical effects. So I'd like to start this seminar with providing you just a basic review, but at a fairly quick pace, of the need for water balance, because all the issues related to management for bacteria and algae and minerals are very much tie into water balance as it sets the stage. Now, the EPA only requires, and you notice this on all the labels of the chlorinating products, that you have the pH and the chlorine level established according to the minimums. The EPA, our big governing body, does not care about total alkalinity reading or calcium hardness reading. The only thing they care is the pH and the chlorine. So when you're testing on a commercial pool, by law, that's the charting. We in our trade have come up with some of these other terms, particularly the name total alkalinity. Alkalinity itself to a chemist just means a high pH material. But for us, in this trade, we think of it as a pH buffer. So it's very common for people to sell a product, total alkalinity, but might call it a pH buffer. Now, the chemical, sodium bicarbonate, we call, and for the most part among us professionals, call it sodium hydrogen carbonate, because it's a chemical synonym and we can distinguish ourselves from baking soda. And the difference between baking soda and what we sell in the field primarily is the granulation. Baking soda bought in a supermarket is milled fine, a lot of dusting, might have a trace anti-caking agent. What we use in the business is sodium hydrogen carbonate, is a granular material that goes into the water quicker without any flying or dusting. So there is a slight technical difference. When you use total alkalinity to attempt to reach an average of about 120, and 120 is considered the midpoint in the range well established by our industry of 80 to 150. Certain pools are going to require somewhat lower total alkalinity, other pools best to have them a little bit higher. In particular, plaster pools or any pool that's run with high pH material such as sodium hypochlorite, calcium hypochlorite like the PPG or the pulsar systems, or commercial pools, or salt generators. All three of those tend to be pH rising systems. It's best to run those pools to a lower level of total alkalinity. Pools that are run with trichlor, which is an acidic component, you'd want to tend to run their alkalinities a little higher. So since I can't publish charts for every aspect, we take the midpoint to 120, and that's your target range. This shows you the quantities based on the size of the gallonage, capping at 30,000 gallons. So certainly if you're talking about a commercial pool with 100,000 gallons, you would look at the 10,000 gallon row and just add a 0 to those numbers. Once you bring the total alkalinity into approximately 120, the pH automatically rises gently and most of the time moves into the range of 7.2 to 7.8. Now, if you take a second to look at the monthly chemical effects chart, you'd see in the box on the top the standard approved industry ranges, pH 7.2 to 7.8, total alkalinity, here we publish 100 to 150, calcium hardness in a range, stabilizer, cyanuric stabilizer range, and TDS, total dissolved solids. And we'll comment on all of those ranges shortly. Total alkalinity is a cousin of pH plus. And this is always in a kind of bit of confusion. You can raise your pH using either of those products, either pH plus, sodium carbonate, or total alkalinity, sodium hydrogen carbonate. For every 2 pounds, from just strictly a pH raising point of view, you need 2 pounds of total alkalinity to achieve the same pH raising influence of 1 pound of pH plus. So why would someone want to use the alkalinity? There are 2 important reasons. Why use 2 pounds of something when you can use 1 pound? And they're about the same cost. And the reason is safety and reactivity. Sodium, total alkalinity powder, if you tip accidentally, dump a whole bucket into it, you'll never have a pocket in the water where the pH is higher than 8.2. If you accidentally dumped a lot of sodium carbonate, pH increaser, into the water, there's no stopping that initial pocket until the whole thing supply homogenizes. This is a big issue. And in that pocket, the pH will zoom up to 9 or 10. At that point, it's very easy for any calcium in the water or minerals in the water to react and give you massive cloudiness or discoloration. And the most classic example of that is a pH in an existing pool that had been bottomed out where there was a heater. And you come by and you perhaps take a dip strip or any other technique and you see that all the values are low. pH is low, alkalinity is 0. So you start to go and raise it and you see a smoky blue grayish cloud. That's the reaction of the pH increasing material where you push the pH up with mineral that's hiding in the water. You minimize that reaction by using the total alkalinity powder to get your pH up rather than pH increaser. You just have to use more. Now, along with that, what I do in service, if I have any question and I've got a pool that's crystal clear but bottomed out, low values, I take a fistful of pH plus, and I'll drop it in and watch it closely and see if the water absorbs it. If the water absorbs it nicely, meaning there's no cloudiness at all, that means you're pretty much mineral free. It's one of the true practical tests to know if there's mineral hiding in the water. Now, this is kind of an integrative seminar, and I have mineral concepts information as well. I could save it later, but this is a good point to comment that the testing of minerals is very tricky. The test procedures flunk when the pH is bottomed out. We suffer with this. We talk to Lamont and Taylor and Hock Aquacheck, and the only minerals that those pools can actually test are ions. And then the test kits don't work when the pH is very low. It's common, if not normal. If you have a pH of 5 and you test for minerals, you'll likely come out 0. But if you slowly move that pH up in a laboratory or in the pool and bring it closer and closer to 7, and then do the test, you'll see minerals. It's one of the shortcomings of the test. Also, if there's some sequestrant, some type of a mineral controller added to the water, a coating agent, like an M&M candy, a coating to the minerals, that also causes the test to fail, and it bypasses the test. So it's very normal for minerals that are controlled chemically by a product like Conquest, or Consulate, or Sequisol, or Jax, or this or that. Once it's controlled and encapsulated, it bypasses the test and will give you the illusion that there's no mineral in the water. But there is, you're just not detecting it. And that becomes exceptionally important if the pool is treated with a lot of chlorine, because encapsulated minerals, once they're heavily chlorinated or shock treated, the chlorine will rip apart that encapsulation, the coating that's controlling the mineral, allowing more chlorine to come in, attack the mineral, and make a color, brown, green, blue, and cause staining. Such a tricky business. Mineral control is a tricky business. You can't really trust the testing procedures as well as you'd like to. So, with that in mind, we do have ways of overcoming that, but when you're first approaching a pool, you want to tread carefully, and I found the best test to see if there's mineral hiding is that fistful of pH+. If the water absorbs it, then you're free to go. At that point, you could continue using pH+ to try to build the pH up, or you can use the total alkalinity powder to build the pH up. Such is not the issue on the high side, because if you encounter a pool that already has a very high pH, it's very unlikely that mineral will be hiding in the water, because at that high pH it would have already had plenty of reason to react with something and fall out, either as a precipitate, a discoloration, or a cloudiness. If your pH is high, you need to move it down. You have two choices. You can use pH decreaser, a granular, or you can use liquid muriatic acid. And in the bottom of the total alkalinity guide, I have the conversion there listed. 10 pounds of dry acid, pH reducer, has the same power of 1 gallon of muriatic acid. You could put a pencil to it, you could do the cost, you can make your decision. For most homeowners, if they have modest applications, needs to lower the pH, the dry acid is the right product. In the summer heat, muriatic acid is difficult. It fumes, it's dangerous. Dry acid is much more forgiving, pH reducer. But if you have large needs, it's not economical. Let me tie this issue of acid into the salt pools and any pools that are in systems where the pH tends to run high. All around the country, salt chlorine generated pools tend to push up the pH. The higher and the faster you run them, the more the dial is turned up to give 3, 4, 5 ppm of chlorine, the faster the pH influence will be. And the only things to offset that will be rain, acid rain, and nothing else that is likely to help offset that. Those pools tend to have a substantial pH decreasing need. How much? About the highest I've ever seen was 1.5 gallons of muriatic acid for 30,000 gallons, a big backyard pool, 1.5 gallons a week. That's 15 pounds of dry acid, pH down, per week. At that point, if you have substantial needs to lower the pH because it's just the way the pool is running, definitely stay with the liquid acid. pH decreaser is sodium bisulfate. You do not want to continue to feed sulfate into the water. Over a period of time, it's going to build up and has the potential to react with calcium. This is a small but growing issue as the number of chlorine generators increase and the need to reduce the pH. Once calcium, if there's a substantial amount in the water, grabs onto enough sulfate, you get a funny haze that you can't break down. Calcium sulfate is gypsum, wallboard, and it will cause a residue and even a potential scale that can only be sanded off and only filtered out. So it's best to stay away from, or to stay only with the muriatic acid where you have substantial needs. Just a few days ago, I was helping a customer in Hawaii through our Western group where they were discussing the idea of using dry acid. And I said to Keith, the owner of this company that we do business with in Honolulu, tell me how big the pool is and how much muriatic acid you're currently using. And it was a big number. I said, you can't do it. And they wanted to because they didn't like the dilution and handling and fumes in a closed environment with the use of the muriatic acid. I said, technically it's going to give you troubles down the road.